Thank you. So good morning to everybody. So the big subject of this morning will be energy management, reducing cost and championing innovation. We have currently three guests that will present and illustrate this subject. Juan from KBR, who is still trying to connect, will arrive later on. And I propose to leave the floor to Claudia in order to introduce herself. And so, please, Claudia.
Very good. Thank you very much, Romy, and I hope you can hear me okay. And good morning to everyone in the UK. I hope you guys are going to enjoy this event. So, Claudia Zuluaga, a former global principal digital product manager for global Dutch Shell, and recently or currently I am board director and the founder of The Future is 50/50. Thank you.
Thank you very much, Claudia. Please, Alan.
Hi guys, Alan Gelder, VP for Refining Chemicals and Oil Markets. For those who don't know, Wood Mackenzie covers the oil and metals value chain, so commercial insight on market and assets, and so very deeply interested in establishing how many of those assets survive and thrive as we go through this energy transition. That was a slide I just wanted to show, actually, and gives an idea of the challenge that we see facing the refining industry, for which the pandemic has not helped. So, presentation gave yesterday talked about a number of years of 3 years of demand loss. What we're seeing are major refinery projects being delayed weeks, months, not being cancelled. What that's leading to is a structural oversupply of refining capacity globally, and what that means is low utilization. And if we put our forecast margins into the European refinery landscape, 2023 we're looking at possibly 2/3 of the refining sector losing money in their refining operations over that period. That really sort of challenges the industry. A lot of things today around cost reduction and energy management. If you look at the scale of some of these margins, a number of sites losing $2, maybe $4 a barrel, that implies cost reduction is necessary, but may not be sufficient to ensure survival. So that's where we think around a lot of the issues around investment for the energy transition. It's investing in those sites that we believe are structurally sustainable to focus and make the best use of those funds. Roman, back to you.
Thank you, David. I propose that you present yourself.
Yeah, good morning. I'm filling in for Henk Hendricks, who was unable to join, but I'm happy to come in. It's a very interesting topic. I'm the managing director for Stella Energy. We partner with energy and extractive companies in helping them with their energy mix, use more renewables, solar, wind, and especially geothermal. It's a great opportunity. So I look forward to talking today about how the energy transition can help the downstream industry reduce costs and improve their energy efficiency to start with. So glad to join in.
So thank you very much. Alan, so I have a first question. Today, what are the actions that you see regarding the energy transition, and how does it fit with this matrix
that you will present? If we can present the matrix.
Yes.
the guys can put this right. Again, this is something we showed yesterday, and we've taken the European sites, refining sites, and looked at how much money they make and what's their carbon intensity. So they're effectively tons of CO2 equivalent associated with their operations. So primarily stage 1 and stage 2, we're not looking at the emissions associated with the consumption of their products, but looked at the energy associated with their delivery, and the earnings from their sites. Clearly, where you want the site to be is in the target quadrant, because you want it to be generating significant amounts of cash, and you want it to have a low carbon intensity. So that's where people want. That's effectively where people want to be. And by virtue of the way we've done an average, you've got about a quarter of the community there, a quarter of the European community there. There are then, if you look at the quadrant higher up, there are sites where they're quite attractive in terms of the cash they're generating. So they're generating cash for reinvestment, but what they're doing is their emissions are relatively high, so higher than the average. So what should their target be? Well, their target should clearly be emissions reduction, and that can be done in a number of ways around, improving energy efficiency, looking at sort of green hydrogen for sort of methane steam reforming, those type of activities and things that we'll discuss in further details as we go through. You go to the sort of left-hand side, then sort of the sites that are weak margin but low carbon intensity, we would categorize those as investment opportunities. But that's really around investing in sort of the configuration, the process kits to give them a positive cash margin. Is that chemicals? Is that residue upgrading? Various things there. But certainly the place that sites don't want to be are those that are financially very weak and a high carbon intensity. Those we think are at sort of threat of either divestment, sort of depends upon the owner and the owner attitude, or potentially closure. And in a sense, we see this type of matrix playing out within the oil majors. Shell is a classic example of a company that over the past year has really changed its views on what a structurally sustainable refining asset is. It's actually heavily integrated with petrochemicals. It is sort of sustainably viable in terms of the margin it generates, and arguably has low emissions or has a means to do that. So what has Shell done? It's high graded, it's announced the sites that it wants to keep. It has sold some sites, so it sold Fredericia recently, but it's also closed some sites. So it closed the Convent refinery in Louisiana late last year, and you look at some of the announcements they've made on some of the other sites. What they're attempting to do for those sites that are attractive is reduce their emissions. They're talking about sort of green hydrogen projects in their refineries in Germany. So lots and lots of things there. The other thing that we see lots of interest in terms of corporate interest is around biofuels and using that as a means of reducing effectively scope 3, so reducing the carbon intensity of the fuels that are being consumed. Roman, back to you.
So thank you very much for this, for showing how this target can help downstream industry adapting to the current challenge. Dave, today energy efficiency typically is a way to reduce emissions. How do you see it could support the adaptation of the industry to this challenge?
Yeah, thank you, Romain. Yeah, Alan's charts are very, very helpful. They basically show that there are facilities which need to reduce their costs, and the energy transition it has a role here. One of the first steps in the energy transition is to improve your energy efficiency. Energy efficiency means your existing facilities are going to run better, less interruptions, less intervention. So we have things called integrity operating windows, which is able to be used with advanced analytics to ensure that we're running smoothly and not wasting energy. We have a lot of IoT devices and measurements and ways of gathering data, process data, but also equipment integrity data. All this is to ensure that equipment is running efficiently, smoothly, not losing energy. So things like fouling of heat exchangers, washing turbines, scaling and deposition. These are all things that existing refineries need to do and are doing to reduce their existing operating costs, get their facility down as much as possible. So we have really great digital transformation technologies and tools to help us with this. We have to watch how much energy are we using, so the energy consumption, how we can monitor that and track that and contextualize that with the conditions and the run rates and everything in the refineries. But also we have to be measuring our emissions. And when we track this, we'll see where we're being efficient or not efficient. Again, improving, reducing the cost, less shutdowns, less expensive shutdowns and startups. And in the future, with more carbon pricing, reducing greenhouse gas emissions will be a really big help for us in the cost profile. So I see that there's a lot of things that existing facilities can do to improve their position in those charts that Alan showed us. Back to you, Romain.
Thank you very much, Dave. In fact, I agree that carbon price could reach, I saw even yesterday figures up to 250 euro per ton, which will completely change our industry in terms of strategy, and a lot of technology will become super interesting. Today, Claudia, to your perspective, what do you see as a limitation for decarbonization today in our industry?
Thanks, Roman. Well, there are multiple ones, but I will concentrate mainly on three key ones. So lack of understanding of the different levers downstream can pull, misconception in terms of costs to implement these levers is the second one, I would say. And perhaps a third one, which we are laggard, so downstream is laggard today, is the lack of transparency of data in the downstream supply chain. So let me elaborate a little bit more. So what are the levers that downstream can pull? I think some of them were mentioned yesterday. So for instance, materials and process efficiencies, renewable power, adaptation of current or existing processes, implementation or investment in nature-based solutions, circularity, recycling are some of them really good levers that are perhaps not very expensive, realizing that they have matured quite a bit. On the misconception in terms of cost to implement these levers, companies don't seem to bring down their emissions simply because they think this implementation is expensive. And of course, margins in downstream are very tight, perhaps even more after COVID or during COVID, as Alan showed. But I think this argument is increasingly flawed. So many levers today can help to address high emissions at a very low cost. And for instance, a study from the World Economic Forum just recently suggests that levers such as circular or recycling, process efficiency, energy consumption, renewable power could perhaps cost the supply chain around 10 euros per ton of CO2. So I would say relatively affordable, and as they mature, they would be cheaper. And the third one that I mentioned, lack of transparency of data in downstream supply chain. So many downstream facilities still have limited transparency about their emissions in the first place, and if they measure it, they are not reporting it. So I would say applying incredible technologies like AirDAR, for instance, that can detect very small leaks in over 20 different types of compounds or fugitive emissions, will make these measurements easier and very affordable at a very affordable costs. And finally, I would say to add to that point on transparency, the mechanisms to establish greater transparency in the supply chain are still immature. I guess we cannot deny that. This lack of transparency means the economics of decarbonization are obscured, leading to the perception that optimizing for sustainability may interfere with the goals of increasing performance or lowering costs that particular downstream facilities may have. So yeah, that's pretty much three of those major challenges the world face, or the downstream world face today. But there are several, a few more. Over to you, Roman. Roman, I cannot hear you, just to let you know. And I'm not sure if I'm the only person.
Sorry, I was on mute. So Juan just joined us. So I will change a little bit and allow Juan to present himself for a few minutes, please.
Hello, everyone, and apologize. There were some technical difficulties on my end, but the fantastic team now here sorted out for me. Good morning, afternoon, and evening, depending where you are. My name is Juan Gomez. I'm the energy lead for KBR Advisory Consulting. My role is to help clients on the decarbonization path. Typically this includes developing a full master plan that goes from energy improvement of their assets, all the way to sustainable feedstock. I'm talking about green vectors here, such as renewable integration with renewable energy, green hydrogen, as well as carbon capture and utilization. How you can link that into their operations. We're talking about sustainability. It's a fantastic topic in KBR. We're going through our own path to sustainability. We reached carbon neutrality in 2019. This was through carbon offset projects, and we aim to be net zero by 2030. On top of this, we're working on our own designs and technology with different partners to have a more sustainable portfolio. We have our own green ammonia technology called K-Green. We work on the biofuel sector with associations with the likes of CRI. And in January this year, two very exciting alliances. The first one with LanzaTech for the carbon recycling technology. And the second one, just a few days later, with Mura Technology on plastic recycling process. That's me. Thank you very much.
Thank you very much, Juan. So, as highlighted by Claudia, the transparency will be a key point for the next step in terms of decarbonization, in terms of energy transition. Today, adoption of renewable dev are a way to decarbonize, definitely. And it will require transparency at the same time to get the credits to be able to declare. How do you see how renewables will be able to help for decarbonization?
So, in terms of renewable sorry.
It is today. Sorry, Juan. I will give you the floor, sir.
Absolutely.
Thanks, Romain. Before I pick up on renewables, again, back to Alan's charts of cost savings and stuff. Right now, there's a lot of waste heat which isn't used. There's a tremendous statistics about how much waste heat we let go without taking advantage of, and there's very attractive low enthalpy solutions, binary organic Rankine cycle type power generation, turbine expanders. Petrobras did a nice study where they showed that they could get a 21% contribution to electricity from these systems and a 22.5% reduction in carbon fuel and emissions. So they are cheaper than closed cycle power generation. So again, this is something that people are starting to look at in existing facilities. Where do they have heat that they're wasting, dumping to water, dumping to the air? Is that something they can make use of to get some additional energy at a cost-effective price? But renewables, meanwhile, have been rapidly scaling, and the cost has come down by 80 or 90%. So the idea of having a hybrid facility where it depends on your location of your facility, but where you can maybe put some solar panels or wind turbines, a lot of good places in Europe, especially for wind, even onshore wind. So the idea of getting additional power from this that where the price is actually getting to the point where it beats conventional power generation is quite attractive for an existing facility. But people are also looking at low enthalpy geothermal resources. So the historic view of geothermal in isolated areas with like large high pressure, high temperature type things is being washed away with the idea that we can get heat underneath our feet in literally thousands of other locations. So all across Europe, people are looking at where they can access this heat and produce more electricity on site. And geothermal is a persistent renewable, unlike solar and wind, which are intermittent. So with geothermal, you would need less energy storage systems. So we have a lot of good technologies and tools to help existing downstream facilities look at their energy mix, be more resilient, get cheaper things, reduce their emissions, and where applicable, reduce their carbon costs. Romain?
Thank you very much, Jeff. That is true, and we see as a licensor that technologies like organic ranking or heat pumps that were or divided wall columns that were quite difficult to justify 10 years ago to our customer are now quite standard in our design. So, or even not standard, but we can propose and we offer to propose them. So it is changing, and there is a lot of, I would say, low temperature heat to be recovered. Today, Juan, on your point of view, what are still the barriers? What are still the challenge to go deeper in decarbonization?
I think there are three main barriers because. But let's start on the technical barrier. I think that's somehow easier to overcome as long as you have the funding. But I think the first barrier is how conservative the downstream industry is. No one wants to be the first to install new technologies. Having said that, I think the top executives now are realizing that the companies need to adapt, or otherwise they risk losing the market share. The second barrier is an economic one. Typically, decarbonization type of projects, or anything that is looking at reducing emission, is competing, on the same budget with yield improvement projects. And we know anything that is related to yield can potentially have a massive economic return. Having said that, our experience is that companies have realized that this is not the way forward, having everything on the same budget. So they are starting to split the budget, and they have an allocated budget, for a sustainable agenda. So that's what we see. And on top of this, to make these kind of projects more economic, we see governments are providing significant grants for these type of projects. And as an example of something we're working on is with the Singaporean government. The Singaporean government offers about 50% of capex for anything that is related to energy efficiency, energy improvements, and decarbonization. Also, another example is the UK government with the Industrial Energy Transformation Fund that has around 300 million pounds for decarbonization and energy efficiency type of projects. We also see the price of greener feedstocks and technology dropping. And we talk about, obviously, we just talk about renewables, how that price of renewable electricity has dropped over the last few years is incredible. Now you can talk about, even in some areas, a value of about 2 cents per kilowatt, which makes, if you're going to talk about green hydrogen production, this almost equal to the price of gray hydrogen. And I talk about technologies. Another example is Nel predicts a drop on the electrolyzer cost of about 75% by 2025. So this looks fantastic. The last challenge, and I'm going to spend too much time on that, is the availability of feedstock. The electricity, the green electricity or renewable electricity. We need a significant capacity. However, we can sort of tackle that a little bit, maybe opening the room for nuclear, even though it could be controversial depending where you talk. Another concern I have is the availability of HVO type of feedstock for refining, but that's still something within KBR we're assessing.
Thank you very much. Alan, this run to HVO, to biojet or biodiesel, and also now the rising of ethanol 2G, how do you see it, how it can answer to this challenge?
It's a really good question, and it's kind of building on Juan's point, which is what the industry needs to do is avoid food versus fuel competition. So there's just an issue of scale and availability. So a couple of things on just some high level numbers on scale. So global vegetable oil production is of the order of 200 million tons a year. Road diesel gas oil demand, depending how you categorize it, is over 1 billion tons a year globally. So vegetable oils cannot displace diesel in entirety. There is the need for low carbon feedstocks. So used cooking oil is a classic example of this. But actually that availability is quite limited. And so what we need are technologies to be demonstrated that can take sort of, rather than food components, agricultural waste components, and convert those into fuel. And it's those technologies need to be deployed, commercialized at scale. Because if not, this issue around sort of HVO, reducing the carbon intensity through more processing of vegetables, actually is introducing a food versus fuel competition. And another sort of a key aspect with that is just simply the price. So vegetable oils, anywhere 800, last time I looked, $800, $900 a ton. You convert that into a crude price, it's over $100 a barrel. So blending these materials in, unless you get the credits from the feedstock, actually is an economic challenge. So liquid biofuels, they're very, very topical, they're very, very great deal of interest, but European Renewable Energy Directive legislation doesn't help either, because it gives a credit, a 4 times multiplier for electric vehicles. So our view is that actually just to comply with the Renewable Energy Directive, Europe doesn't need much more biofuels, liquid biofuels. It needs high quality ones. The issue is then the availability of the feedstock. And if we look globally, the place where the incentives are put in structure to help the industry invest and pull feedstock into it is actually California through its low carbon fuel standard. European assets and sites are not well placed to compete against the incentive structure California has put in place to decarbonize its fuels, which means that's where the center will go. So what's the need? The need is for technology to take agricultural waste to work and be deployed. So it's yet again with this energy transition, this decarbonisation aspect, it's complex, and there are solutions there. But for an industry that's quite conservative, it's often easy to wait and not deploy them because you don't necessarily want to be first if it seemed to be risky. So lots of things in there. Roman, back to you.
Thank you. So finally, you say that some technologies are available. In Accent, we have this futurol for ethanol to G, but there is plenty of other technologies of biomass to liquid or others using agricultural waste, as you said. But these projects still are not rushing. We are still at biojet steps, HVO. So what is missing today in order to get to this transition? What are still the blockage, Alan?
I think it comes down to it's policy and company action. Yeah? There's a need for, if I take a big step back and I look at our view as to what's happening in terms of the energy transition, for the world to achieve anything near 2 degrees C, then actually policies need to change quite dramatically, because without those, we're not going to get the deployment of the low carbon technology that's done at scale, because the incentives for the companies to deploy it aren't necessarily there. So it's sort of regulation. It goes back to a point raised earlier about transparency, so that investors can look at things, and then it's aspects around sort of commercial structures or commercial incentives, which comes into things like carbon pricing. So there's lots and lots of, I'm trying to think of the right word, there's lots and lots of interest, but the amount of things that are truly tangible that companies can rely on to try and experiment or run some pilots, they're not quite in place yet, which means the pace of adoption is as you say, is slow.
Okay. That is going to this point after Juan. So today we saw from the map of the target map of Alan that profitability is a short-term target. Otherwise, the industry will die anyway. So 2/3, it's huge. But at the same time, environmental points are the pressure is increasing. So how innovation can help today? What is coming? What could help to go to this stage?
In terms of, if we go back 1 second on the profitability, you know, the way we see, or the way I see it, is the downstream sector is there to serve a market. So if the market is there and they're willing to pay a fair price, you know, for the products, greener products, the downstream sector will adapt. So what I believe is that the market plus incentive from government, even if we see it through regulations, will get us there. And just to give you a quick idea on the market, so I think the Hydrogen Council estimated that green hydrogen or emission-free hydrogen is going to be worth about $2 trillion a year by 2050, and we see some similar trends. So we have clients that are willing to pay 20-30% above the market price, as long as the products are, you know, labeled to be sustainable. In terms of technologies, you know, there are different type of technology. We talk about, you know, electrolyzers that are getting more and more efficient for hydrogen. We're talking about, you know, carbon capture technologies are getting even more efficient. There are some technologies there that claim to be, you know, 2 or 3 times more less energy intensive than the standard carbon capture facility. One of our panelists also talk about low-grade heat utilization. There are fantastic new technologies. Let's call them new, even though they've been around for a few years. On that low-grade heat utilization, we mentioned the organic Rankine cycle. So I have projects that developed this and last year, where we look at implementing organic Rankine cycle into refineries. There are also new technologies like Q-Pinch that look at that upgrading of low-grade heat recoveries, and they look extremely promising. So I think the technology is you know, are getting us there very soon.
Thank you very much. So when I see here that it's a question more for Dave. Today, regulations are a key drivers. Funding, more or less, is available. We see government funding, but I see also a lot of private funding available. I work a lot in plastic recycling and hydrogen. There, the private funding is huge. So how all these elements can help for energy transition today?
Yeah, it's a dilemma in developed countries. It's quite clear that your access to funding and finance is going to be restricted if you can't address the energy transition. You need to be able to show that. But meanwhile, we have 80% of the world's population in locations that may not have that luxury. They have existing sources of hydrocarbons, and they're trying to increase their living standards, raise up their economies, but maybe they're going to be restricted access to funding and finance. So it's a dilemma, and if they can't provide their own sources of energy, if they can't put their own refineries in, say in Africa, then the refined products will have to come from other parts of the world with a large carbon footprint of making these products elsewhere and bring them in. So, you know, regulators are putting restrictions on emissions and waste, recycling, things like that. Funding and finance, people are doing the same, but it is a complicated situation. I think carbon pricing will help, because it'll make things more clear. So if you want to buy something and from a faraway place, and the cost of making it there and transporting it to you has a higher carbon price than making a refined product, for example, on the ground in a country like Nigeria. So these aren't pure technical decisions. We have commercial business decisions that are impacted by the regulatory environment where we are and our access to funding and finance. So it is pretty complicated, and sometimes people need help with these decisions. Romain?
Yes, so it's clear that for what is everything that is green, there is funding, and less for everything that is, I will say, brown, or historically the fossil origin. Today, there is still low-hanging fruits thanks to digital transformation, thanks to historical way to best-in-class operation. Today, how is this innovation, and we got a lot last 5 years, can serve our downstream industry to reach a higher profitability? It's for Dave.
Who's that? Oh, sorry. Well, there's a lot of great innovation. We've heard about this in some other parts of the conference yesterday and today, and it's making use of these tools. Nothing we can do on the existing facilities on Alan's charts with their sunk costs, but OpEx is quite a big component of their costs. So one of the biggest components of OpEx is, of course, people. So reducing manning, using more centralized control rooms, remote monitoring, remote diagnostics, doing inspections of these facilities with autonomous drones and robots. These are all ways to reduce operational costs. So we're doing our best we can with the existing facilities to reduce those. Of course, these will be much easier to incorporate into future facilities. Future facilities will have the choice of other technologies to process. We heard some of them from some of the other panelists about more efficient use of waste heat. So there's things we can do in the future, but right now, with all these existing facilities, there's things we should do with digital transformation tools and to reduce our operations costs and maintenance costs. Maintenance, there's a very high percentage of maintenance that's the wrong maintenance at the wrong time in the wrong place. So using the digital tools that we have to get this maintenance done correct the first time safely, using things like augmented reality, virtual reality to help the remaining personnel in a facility do a better job, is going to help us cut our costs tremendously and also be safer. So I think there are good things that we see operators adopting, and we heard some of them from Shell yesterday, for example. Romain?
Yes, that is really something. For example, also the digital transformation has bring everything around fleet management that is quite impressive. And Claudia, today supply chain is not so easy to get decarbonized still. Do you have some innovation ideas, that example that you could share on how to decarbonize the supply chain?
Thanks, Romain. I will not say they are innovative. They're just ideas or suggestions that require a partnership and collaboration across the value chain. I'm just going to mention a few. And the example that I'm going to give is not from the downstream industry, but I will tell a little bit more about it. So first one I would say include sustainability metrics into competitive tendering processes and reward those that are participating in the climate action. I would say another one is major players have a major role to play. And I think if major downstream players get together to define joint standards and take a joint action through the supply chain, they could themselves impact or create a positive effect in a significant portion of global emissions. Probably another one, set ambition reduction targets and publicly report them. I think this is where we are really, downstream industries really lacking. So there are bodies like Science Based Target Initiative. They have already developed certain pathways for different sectors. And if those pathways are non-existent, nothing stops us to get together with other companies or partners in order to develop them. In one example, which I mentioned, which is not in the downstream industries, in the beverage industry, and was also reported in one study by the Boston Consulting Group, is Carlsberg. And I'm keen to bring it here because the downstream industry, being so conservative, we need to open up to learn from others. So Carlsberg they have targets to reduce what they call their beer in hand footprint by 30% by 2030. Around 85% of emissions are out of Carlsberg direct control. So the company works with suppliers to encourage a commitment to science-based targets. And they announced in February 2020 that around 110 suppliers in their supply chain had already made a commitment. I mean, I think this is incredible. Similar case in the technology industry is Apple. They have obtained, if I remember correctly, around 75% commitment from different suppliers in their whole entire value chain. So back to the Carlsberg case. So to establish transparency, Carlsberg has teamed with Carbon Trust to develop an advanced supply chain emissions calculation model. And the model uses supplier-specific emissions data. And this data comes from suppliers' individual primary data for the materials and supply to Carlsberg. If the data is not available, then they are looking to develop estimates based on material and locations, specific sectors. So that's, I think, an incredible case that when I was doing my research, I thought it was, it has a lot to say, and also the beverage industry is not easy either. So we could learn a lot from those industries as well. Over to you, Roman.
Thank you very much, Claudia. So, Alan, today the optimization has to be done at the whole value chain, just not only in the refinery or at process units level. So today, do you see innovations that or energy efficiency strategies that could help to embrace the full value chain?
Well, I think we hear of things. I'm not sure I can point to any. Perhaps the other panelists are closer to this. Maybe Juan can when it comes to him. But we hear of this. It goes to a lot of what Claudia talked about regarding the need for looking at around the entire value chain, not just finishing at the refinery gates. And it needs the industry to almost look at emissions as it looked at safety, because you think about safety within the downstream industry, and you have these companies that compete with each other quite fiercely, but they're very collaborative in sharing their learnings and best practices around safety. We almost need to think about emissions and energy efficiency in those ways, so that best practice becomes known, can then be shared and then adopted more quickly. The challenge is it is a source of competitive advantage for some. So we'll kind of have to bear that in mind, but it does need things to be collaborative. I think one of the challenges we must face the downstream industry pretty squarely. Conversion of fossil fuels to refined products for their combustion in internal combustion engines is a source of emissions. If the regulators choose or promote alternatives, electric vehicles say, then the downstream industry will get smaller. because the demand for gasoline will fall, in which case they need to think about what are the products, value chains where those emissions are not so critical. That points us towards petrochemicals. So this is something else to bear in mind. We've seen elements of actually, I think recently Occidental, through one of the divisions, sold carbon neutral crude, where they looked at the emissions for scope 1, 2, and 3. There'll be some aspects around that, but if we're looking about overall energy efficiency and overall environmental impact, we mustn't forget that actually what this could likely need is the less call on conversion of crude oil. Refineries still have a value. They are a conversion industry. It's just that what they won't be doing is converting crude oil. Hence, that comes into the comments that I think, Roman, I think you raised, that petrochemical recycling really seems to be taking off as the technology's there, and there's lots of private money flowing. So what does a structurally sustainable asset look like? We think it's an integrated refinery chemical site in an industrial cluster that can decarbonize, because it can justify its place in the world. So the industry also needs to bear in mind what's happening more holistically and what's going to happen to the demand for what it currently does, which is crude oil conversion. So that's not a particularly pleasant picture, but one to be acknowledged. Back to you.
Thank you, Alan. We have questions, but one before that. These questions, I see every day opportunities of integration of plastic recycling with existing assets. I see every day the opportunities of hydrogen generation and co-valorization, for example, of oxygen in the refinery. There is many opportunities. So big change, but many opportunities. How do you see it also on your side, in KBR?
Yeah, I mean, the opportunities are incredible, and Alan mentioned the challenges that you're going to have on the refining industry if or once all the gasoline and diesel moves to, let's say, hydrogen or electrification. I mean, the refinery, I think we still have the place, because jet fuel, bunker fuel are going to be predominant, at least for the near future. Oil base. Then we have the asphalt and bitumen for the roads. So you're going to have also part of that coming from the refinery. In terms of what we see the same opportunities that you are mentioning. I mean, I see my clients asking for, how do I use renewable feedstock, talking about HVO on the refining. We have done a few studies on that. It's quite interesting challenge. Also on the petrochemical side, using a more, let's say, a greener feedstock. We're talking about plastic recycling. Companies are looking into that. And one point I want to mention is that collaboration to try and reduce emission. So I've been working on something that is quite interesting. You have multiple sites on one industrial cluster. So these sites have decided to work together to try and reduce emission by making the different clusters, again, the site-wide operation more efficient from the energy point of view. And the savings are incredible, actually. I mean, so once the challenge is to make them all share the benefit. But once you overcome that, the benefits of some sort of site-wide industrial cluster integration are incredible.
Thank you very much. We have few questions, so thank you very much for the. Now we'll go to the Q&A. I don't know how much time we're still remaining, but let's consider we have few. The first questions we got from Rajesh Sharma was on electrification. When we start to imagine, for example, in a country like Australia or Chile, of electricity as almost very low cost, what will look like the downstream industry in this area? Who wants to take this question? Okay, Alan, please.
It depends. To a degree, you can. There's two ways to look at it. If it is very, very cheap electricity and the government is really promoting electric vehicles, the downstream industry will be a lot smaller. Yeah? For those that survive, what you can then look at is how do you deploy that electricity within the refining sector to decarbonize it. So again, that sort of green hydrogen, you sort of go to electric furnaces and improve fuel efficiency on those sorts of things. So there's an element as to what's the addressable market for what the refinery is doing, but then there's also how do you deploy that low carbon energy source to reduce the impact of the downstream sector. So there's probably a balance between those two.
Okay. Alan, Juan, I have another question for you, Juan, which is, I have not the answer, so you may not have it, but please. Still a question from Rajesh Pharma. Oxy supplied net zero carbon crude to Reliance in India recently. What is your opinion on refiners demanding net zero carbon crude in the future to reduce their carbon footprint? How do you see that? Is
that me?
If you have the answer, Alan, why not?
I'm not sure I have the answer actually, because it's going to be interesting to see, because that crude was declared carbon neutral for scope 1, 2, and 3 emissions. So actually, you can argue that the people who benefit from that would be the consumer of the associated transport fuels, who can consume them without feeling that they're contributing to any emissions. How much do they value for that? Where do these emissions get paid for? It's quite an interesting debate we need to see going forwards, because one of the panelists before mentioned things about carbon pricing. Carbon pricing may have been you, where carbon prices could be very high. I did a calculation yesterday and looked at UK fuel excise tax and said, what is that if you make it equivalent to a carbon price? It's over $250 a ton, but that's on the consumer, not something that the industry can capture and take value from because of where the taxation point is. So how governments adapt to this, particularly Western governments that tax fuels heavily, is going to be fascinating to watch, because you can argue there's an implicit carbon price already in the value chain that's very high. It's just in the wrong point in the value chain to get the outputs that they want.
Yeah. On the continuity, I will ask to Dave. Today we see some project of carbon storage rising. We see some of them. Mainly the storage will be done in enhanced oil recovery applications. As a CO2 applications, like mentioned by Juan before as Lanzatec, how do you see the different application of CCU transforming the downstream sector step by step?
Well, there's some good developments in the UK and in Norway, looking to see if there can be such a thing as an industrial cluster that could capture CO2. That's I guess I have to declare my bias. I'm not really believing that carbon capture from the air is going to be available anytime soon, but carbon capture at source is very attractive. It's already concentrated, it's there, and if we could do some of these industrial clusters which could collect it, process it, and then send it in pipeline to depleted oil and gas reservoirs in the North Sea, that seems like a wonderful opportunity for UK and Norway to do more of that. And perhaps there'll be other refineries in other locations, depending on where they're located, how concentrated they are. A place like Singapore has a large concentrated industrial area, and there's a lot of depleted reservoirs in neighboring Indonesia and South China Sea. So maybe we'll see more of this for refineries, I hope.
So thank you very much to all of you for this panel. We see that as always, the downstream industry is slow to move, but is always moving. So there is opportunities, there is ideas, it is pushing. We see all the industries that is fastly moving to these new opportunities, even if the time is not easy, for sure. So thank you all for this wonderful panel, and thank you, Adam, for welcoming us. Thank you.